Hello, myself Anil BA. Today in this video we are going to discuss about backtracking with its example and with the drawbacks. So let's know the content of the video. We are going to content about introduction of backtracking. What is backtracking? Backtracking example, backtracking in system software, backtracking in compilers, alternatives to backtracking, benefits of backtracking, backtracking in real world applications, and the conclusion. So let's discuss one by one. So let's discuss about the introduction of backtracking. Backtracking is a powerful technique used in computer science to solve problems that involves making a series of decisions. It is a methodological approach that involves trying out different possibilities until a solution is found. Backtracking is an essential tool in many areas of computer science, including artificial intelligence, automation, and game theory. In this presentation, we'll explore the concept of backtracking, how it works, its benefits and drawbacks. We'll also discuss a real-world application of backtracking and alternatives of this technique. By the end of this presentation, we will have a solid understanding of backtracking and its role on computer science. So, what is backtracking? Backtracking is a powerful problem-solving technique used in computer science. It involves trying out different solutions to a problem until the correct one is found. This method is especially useful when there are multiple problem solutions but only one of them is correct. Backtracking allows us to systematically eliminate incorrect solution until we found the right one. To better understand how backtracking works, let's consider the example of solving a maze. Image you are lost in maze and need to find our way out. You start by taking a path, but it leads to a dead end. Instead of giving up, you backtrack to the last intersection and try a different path. You continue this process until you find the correct path that leads you to the maze. This is essential how backtracking works. It involves trying out different solutions and backtracking when they don't work until the correct solution is found. So let's see the example of backtracking. Consider a game where you have to navigate through a maze. At each intersection, you can choose to go left, right, up, or down. However, same path may be blocked and you need to backtrack to find the alternative route. This is an example of backtracking in action. Backtracking involves systematically trying out different solutions until the correct one is found. In your maze example, this means trying out all possibilities first until you reach the end. If you encounter a dead end, you backtrack to the previous intersection and they try different path. This process continues until you find the correct path. So let's discuss about backtracking in system software. Backtracking is powerful technique that you can be used to solve many problems. However, it is important to note that it is not always the most efficient solution, especially when it comes to system software. One of the main drawbacks of using backtracking in system software is that it can be very slow. This is because backtracking involves exploring all possible solutions of a problem, which can be time consuming and resource intensive. Tracking in compilers. Backtracking is a common technique used in compilers, but it has its drawbacks. One of the main issues with using backtracking in compilers is that it can be very time consuming. This is because backtracking involves exploring all possible solutions to a problem, which can be take a lot of time and resources. Another issue with using backtracking in compiler is that it can lead to memory leak. This is because backtracking involves keeping track of all possible solutions to a problem, which can be quickly used up a lot of memory. As a result, backtracking is not always an efficient solution for certain problems in compilers. Alternatives to backtracking. While backtracking can be a useful tool in certain solutions, it is not always the most efficient solution for problems in system software and compilers. These are the several alternative solutions that can be used instead of backtracking, such as dynamic programming, branch and bound, and constant satisfaction algorithm. Dynamic programming involves breaking down a problem into smaller subproblems and solution each subproblem only once. This can greatly reduce the amount of time and reduce need to solve the overall problem. Branch and bound is another technique that involves exploring different branches of problems trees and eliminating those that are not feasible or do not lead to an optional solution. Constraint satisfaction algorithm use logical constraint to narrow down the possible solutions to a problem, making it easier to find the correct solution. Benefits of backtracking. One of the main benefits of backtracking is its ability to efficiently solve problems that involve searching for a solution in a long search space. Backtracking algorithms can quickly eliminate large portion of the search space by intelligently tuning branches that are guaranteed not lead to a solution. This makes it an ideal tool for solving problems such as n-queens problems or Sudoku puzzles. Another benefit of backtracking it is versatility. It can be used for solving a wide variety of problems in computer science, from finding the shortest path in a graph to generating permutations of the set. Its feasibility and easy to implement make it valuable tool for a programming toolkit. Backtracking in a real-world application. Backtracking is a powerful tool that has many real-world applications. One example in this field of bioinformation, where it uses to analyze DNA sequences. By using backtracking algorithms, researchers can identify patterns and mutations in DNA strands, which can lead to breakthrough in diseases research and treatment. Another example of backtracking in action is in the world of finance. Backtracking algorithm can be used to optimize investment portion by analyzing past market trends and predicting future outcomes. This allows investors to make more informed decisions and potentially increase their returns. At the end of video, what and all we are going to discuss in this video. We have explored the concept of backtracking and its application in computer science. We have seen how it can be used to solve complex problems, but also discussed its limitations in certain scenarios such as system software and compilers. It is important for computer science students and professionals alike to understand backtracking and its alternatives in order to make informed decisions when approaching problem solving. By having a solid understanding of the technique, one can make more efficient use of time and resources in finding solutions to different difficult problems. Thank you.